The camera as a piece of technology has a very special place in society. The use of a camera is a very emotional experience. It allows us to express ourselves, it allows us to interact with each other, communicate with each other in a very powerful way. In the computer vision lab at Columbia, what we try and do is develop new types of cameras. These are what we call computational cameras that essentially are the convergence of the computer and the camera. And about 4 or 5 years ago, I started thinking about how what we do in the lab might have impact at a more social level, a more basic social level, a more human level. And that's how I began to think about potentially developing a camera for children, for education. Bigshot is a digital camera, and it has many unique features. We call the camera Bigshot. It's actually a play on words. It's the idea of taking young kids in underprivileged schools and turning them into big shots. The Bigshot project has essentially 3 main missions. The first is learning by building. And that's the idea, of course, building the camera. It's a hands-on experience, and you learn these concepts in science and engineering. The second is we teach them very simple rules of photography and then have them create by using. And then finally, it's expressing by sharing. And that's an important concept. The idea there is for kids in very different communities, from very different socioeconomic backgrounds and cultures, to share pictures with each other. We field tested the camera in 3 cities, New York City, in Vung Tau City in Vietnam, and Bangalore in India. But we also were looking for diversity. We wanted to look at inner city schools where the kids were from a certain socioeconomic background, but also privileged schools where they have access to all kinds of technology, but we wanted to prove to ourselves that even those children would enjoy learning and building the camera. The idea here was not to create a device that was an inexpensive toy. There are many of those in the market. The idea was to create something that could be used as a platform for education, and that's a real challenge. So the first thing about the camera is that it comes as a set of parts, components, building blocks, where each building block allows us to communicate, to teach the students an important science and engineering concept. It is a green camera, so to speak. It actually has a dynamo, and which you can crank up. And so even without the use of a battery, let's say you run out of a battery during a shoot, you can crank this about 4 times and take a picture. Because the amount of current that you need to take a picture is pretty small. So it's actually a workable solution. It's a good fit for a dynamo. And the third one is, which really sets this camera apart from other cameras, is that we have this sort of Swiss Army knife model for the lens. That is, you have a lens sitting inside the camera, but you have other lenses on this wheel. And if you bring this into a particular position, you get a normal, what we call perspective, linear perspective view that any camera produces. You put it in a second position, you get a bit of a panoramic view, about 80 degrees. And then the third position in here actually gets you to a stereoscopic view, which is a 3D image, where you can perceive 3-dimensional objects in the scene by wearing glasses. And as you can imagine, kids love that feature. You know, I have to say, I am addicted to the pictures taken by the kids. I can't get enough of it. We have thousands of them, and I just keep looking at them, because the fact that some of these kids were using the camera, for the first time, and they were able to frame what they thought was important and capture that moment so beautifully, it's really remarkable.